Hello and welcome to today's Epiphany Algebra tutorial. Today we'll be walking through how to use Epiphany to enter and solve a variety of algebra problems, including quadratic equations, absolute value equations, equations with exponents, and other similar problems you might see in Algebra 1 and Algebra 2. There also is a general tutorial on how to use Epiphany and get things set up, including working with your teachers and tutors. Please see the link in our YouTube channel for links to that and other videos on how to use us. And please like and share our YouTube channel. So let's jump right into it. I'm going to share my screen here. And we'll log in as the demo group here. And I've got our demo all set up for us. We're just going to jump right into doing some math. So I'll start with this linear equation here. The first thing to note is that every problem in Epiphany for now must be an equation. We are set up to handle other types of equations. And let me demonstrate that here for a minute. I'm going to go back to this demo, and I can enter a new problem. I have all these other types of equations that I can enter, including some that involve blank space or free text entry where we're not going to be checking things. Eventually, we'll support problems that just involve expansion or simplification, factoring, those sorts of things. But for now, everything needs to be an equation. So we're going to continue to work with that context, and I'll show you some workarounds to handle problems that are of that type when we get to them. So we're going to go step by step through this problem. You can use whatever method you want, take whatever steps you want. We recommend taking steps that are appropriate for your level of math. We're going to start out by subtracting x from both sides, and I get 2x minus 5 equals 7. Next, we're going to subtract 5 from both sides, and I get 2x equals 2. Oops, I made a mistake. What did I do here? Oh, well, I did the same thing to both sides. I wanted to subtract 5 from both sides, and then I simplified both sides here. But I see what I did. I accidentally added 5 to the left. So sometimes I have the system set to a very verbose mode right now. It's going to have a lot of comments, maybe more than it might usually have. But it might ask you what you did in certain cases to keep notes on them. And as I save this, it's going to place a note in the comments here about what you did. And later on, your teacher might be able to access as well, might be able to look this over and share comments about recommendations or things that they note as well. So now that I see what I did, I'm going to go ahead and fix this. 2x equals 12. And I'll take the last step and say that x equals 6. And I am done with this. Once I'm done with this problem, I can go ahead and go on to the next problem. I wanted to also mention that we at Epiphany will enter your problem sets into the system for you. You can enter this, one question at a time, but we'll also do it for you if you just send us an email at support@epiphany.com with a picture and your user ID. We'll get this set up for you so that you can get to using Epiphany as quickly as possible. All right, our next problem here involves combining like terms, and I wanted to highlight a couple of ways of entering. I've been using the text entry mechanism. A caret is used for exponents, and there are various keyboard shortcuts, but we also have a GUI interface, either for use on a desktop or for when you're doing this on a tablet or on your cell phone. We have mobile and tablet views of this as well, with a variety of functions ranging from regular algebra functions to trigonometry, complex relationships, and calculus functions as well, various things that you might need. We also have support for Greek variables and other symbols related to set notation. So I want to simplify this. We're going to combine like terms. And the first thing I want to do is I want to reorganize these to put the same things in the same places. But I really don't want to type this all over again. So this little symbol here is a copy, and this one here is a paste. I'm going to paste it in this window, and I'm going to minimize my GUI for just a moment. Let's just move things around here. And I can select a portion of this. I've got my XY squares. I'm going to select this. And when I let go, you'll notice it's a different shape, but I can still Control X to cut it. And I can move it over here and paste it. And let's see, I've got x squared y's over here. Let's move these all together. And then I've got 8x and move that with the other x. Oops. I accidentally deleted too much. I hit Control Z to undo what I just did. Control Y will redo it. Control Z undoes it. I think I might have messed something up there. Let me just double check that I did not break anything. There's my x squared y. And I'll move this 8x over here. And this just becomes, I'm just going to combine those right now and say it's plus 9. And here's my next step. Good, got that right. Now I can just combine everything, and I'm going to, I'll copy and paste again. Why not? This is just going to become 2x cubed y squared minus 7 plus 4 is minus 3. And we have 5x here, and we're done. Notice that this might have been a problem that asked you just to simplify a set of expressions. We've set another variable equal to that expression. That's a way you can handle problems that don't have equations. Just set another variable equal to them for factoring or expanding a function or things like that. And that'll all work just fine. So we can copy a whole line. We can even copy parts of a line. All that is available. This next problem is similar. This is a FOIL problem. We've set another variable equal to it, and I'm going to go ahead and expand this out. Rather than using FOIL like we normally would with the first, outside, inside, and last, I'm going to take each of the first pieces and distribute them. So I'm going to say y equals 2x times x minus 4 plus 3 times x minus 4. And I'm doing this for a reason. This is going to produce a message that it's not correct, even though it is. The reason is that there are two best practices in using Epiphany. One is use explicit multiplication, especially when dealing with variables. And the other is use parentheses. Not so much in situations like this, but in situations where you have a sign or a logarithmic function, things that are actually more advanced than algebra in general. It's important to use parentheses there so it knows what goes where. And sometimes it's mathematically necessary as well to make it accurate. In this case, if I just put a multiplication symbol in here between the 2x and the x minus 4, this is going to be correct. In the initial incarnation, the system thought that x was a function of x plus x minus 4. And so now with the multiplication symbol, it's clear what it's intended to do. And that also applies for things like e and I as well. If you put a multiplication symbol after it or before it, that will often help us understand what you mean. So next step, we get y equals 2x squared minus 8x plus 3x minus 12. And we can finish it up, y equals 2x squared minus 5x minus 12. And we're done. Similarly, if we have a factoring problem, we want to factor this into two terms. We could do the same thing here. I'm not going to, well, I'll just go ahead and enter this answer. It's going to be y minus 9 times y minus 4. And I'll just say done in next problem. We're done with that. Hello. Something happened there. Very good. And now we're done. Okay, so in this problem, it's a literal equation. We're trying to solve for the variable d. And so I'm going to take this once again, step by step. I'll type this out. I'm going to multiply by 2 on each side the first time. Say 2y equals a plus b plus c plus d. And this will be my step. But by the way, if I wanted to express that whole thing divided by 2, if I hit divided by 2 now, it's just going to put d over that. So I'm going to undo that. If I hit shift and the left arrow, I can select a piece of this, and now my fraction will go over that whole thing. So that's another entry mechanism that can be useful. And I can now finish this up, say that 2y minus a minus b minus c equals d. And I'll flip that around just because I want to. And now we're done. All right. Next, we're on to a quadratic equation. And I want to show how we would handle a problem like this. So the first thing we're going to do is take everything and move it to the left side of the equation. We're going to subtract 2x squared from both sides, and we get x squared. We're going to subtract x from both sides, we get minus 5x, and subtract 8, and we get minus 6 equals 0. Let's continue from here. The next step we'll have is factoring this into x minus 6 times x plus 1. And now, how do you enter multiple solutions? We have two mechanisms, actually three mechanisms to do this. The first is I can enter this as x equals -1 or 6, the actual word or, and that will be accepted. Some people like using the word and, but we use or instead of that because or is actually more correct. You can also say that x equals, and with braces, -1 comma 6. It's not actually equal to the set, but this is how we choose to enter this information. This is a way of entering it as well. And you could also solve this with the quadratic equation. If I wanted to, I could say x equals, and I'll make a fraction, negative, let's do this, -5, plus or minus. There is a shortcut for it, but I'm going to show right here. We have the shortcut in our functions. I just -5 plus or minus. Backslash square root is SQRT is the square root shortcut. Square root of -5 squared minus 4, 1, -6. And there is an issue with and it's just with my PC right now with this web interface. You'll notice that some of the graphics are not working properly. I'm working on that, and apparently it's only a few people who experience this. But if you do, just know that we're working on it. So this is how you could express the same thing with the quadratic equation. Then you can work through and find the answer. And I'm going to mark this as done. We don't have specific checks on when someone says they're done at this point, but we're going to be adding those soon. Okay, so the next problem here, we're going to look at a radical simplification. And again, we can use square root functions here and other functions, but I'm going to take a different route. I'm going to switch over to our mobile interface to show you that, along with our handwriting recognition mechanism that allows you to do this with a tablet or with handwriting recognition on a mobile device. Bear with me 1 minute while I get over to the mobile view of this question. And here we are in the mobile view of Epiphany. There's a similar tablet view as well. And we have the same types of tabs, but they just show up in different locations. Some of them are at the bottom, some of them are on a drop down. And we're going to continue with that same problem we were just doing. Y equals the square root of 48. We're going to simplify this. And I'm going to turn this sideways and look at this in a different view from my phone. And now, I don't want to do that. Let's clear that mark. I'm going to enter my next step. Y equals square root of 16 times 3. My handwriting is not very good, but it figured it out. And next, I'm going to simplify that a little bit more. Hit the X button. I need to make that mark. Y equals square root of 16 times square root of 3. Hide that. Continue. And y equals 4 square root of 3. Enter. And so you can do these with handwriting recognition just as you would through the keyboard or through the GUI. Those are also available. And I'm going to go back here and hide this. And I'll mark this as done. Let's continue with the next one. Absolute value of x minus 4 is equal to 1. You can get started on that. And x minus 4 equals plus or minus 1. Enter. x equals 4. Oops. Let's just remove it. Try that again. X equals 4 plus or minus 1. Did it get that? Didn't get that. Let's get that right. Plus or minus. Plus or minus 1. You can erase things by just slashing through them as well. Let's hide that. That's getting in the way. And we can finish this up. X equals 3, 5. Like that. There we go. And we're done. All right. Let's go back, and I'm going to pause again for a moment while I switch back over to the desktop version of this. And here we are, we're back on the desktop. We have finished this absolute value problem. We also support nested absolute value problems, but they can be a little tricky, making sure the right absolute value symbol winds up with the right one. So just watch for that if you choose to try that sort of problem. Let's go on to the next problem. And this time we have an inequality. Let's divide by -2, and I get x less than -4. Oh, wait a minute. I have to reverse the sign. I'm actually going to show something else to you right now. Let's say I accidentally put in x equals 4 as the answer to this. Right now, that causes a problem for us. We are comparing two different types of things under the hood. If you see something like this, it's an error inside of our system. They should always be a seamless transition. It shouldn't cause a server error or anything like that. We capture that. We take a look at those on a regular basis to see what we need to improve. Also, feel free to share site feedback or report a problem if you run into this. But yeah, this is what you'll see if something comes up. And you can just continue. It'll compare with the last step again. Oh, I meant to say x is greater than 4, and I can finish this problem up. Well, oh, x is greater than -4. That's what I meant. I want to add a note here, and that is Epiphanie is designed to handle any math constructs. You can enter anything that can be described in LaTeX here, which means that you can put math in here that we definitely cannot handle. You know, multivariable equations. You can enter partial differential equations, things that we would definitely have trouble with and not be able to provide advice on. That's our goal. You can always enter things in any way, and if you want to, you can always enter them without a review. If you just want to enter complex symbols, be able to use this as a way of entering something for a word problem, for example, or a problem involving steps that you're not going to have us check. You can do that. But then, just there might be some symbols that if you have us check them, we don't necessarily recognize them, or they might cause us some problems. So those options are available, and I'll show a couple other things here very shortly on how we can use some of the options to continue if there is something that Epiphanie doesn't immediately recognize. So this next problem involves exponents, and we're going to simplify a property of exponents problem. I'm going to say that y equals a to the 4th, b to the 4th, c to the 6th. And actually, I want to show something here. So if I wanted to, I could say, if I'm in the exponent like this and I hit the equal symbol, it's going to pop out of the exponent. We did that intentionally. Other symbols will stay in the exponent. But if I type 2 plus, the plus will come down like that. If I wanted to say 2 plus 4 up here, I'd have to put the plus as not the last symbol in the exponent. But and I made a mistake with that, but we're going to continue with this as it is here. And it'll note that we made a mistake. I could add some comments if I wanted to, and said, I'm just going to recognize my mistake and fix it here. This should be the 8th power instead of the 6th. And I can finish this up with combining these last 3 pieces. I get a to the 7th b to the fourth, c to the eighth, and I'm done. So in this next problem, I want to show an example of how you can do substitution. So I'm going to say that I want to substitute 5 for x. Well, what I have to do is come over here, and I'm going to plug in and substitute, and I'm going to say that x equals 5. I could also say that x equals some expression, x equals z squared minus 2 if I wanted to. But I'm just going to say x equals 5 for this problem. I'll save that. And now I'm going to plug in 3 times 5 squared plus 2. And y equals 77 is the final answer. I'm skipping a step or two there, but there we go. So you can plug in, if you want to say, have students, if you're looking to solve a problem where you're trying to plug into a function, you can do that with Epiphanie as well. Here's a problem that involves a rational equation you might see in Algebra 2. And we're going to take the first step in solving this, and that is we're going to set the numerator. Well, let's factor the numerator to start with. I'm going to say that this is x minus 3, x minus 1 over x minus 1 equals 0. And we're going to cancel the x minus 1s. I get x minus 3 equals 0. If I do that, it's going to work out the right way, but I want to try something different instead. I'm just going to set the numerator equal to 0 and see what happens. Because after all, the numerator has to be 0 in order for the fraction to be 0. And it's telling me there's a mistake here. Well, the reason is there's an extraneous solution in this set. X equals 1 is not a valid solution because it's not part of the domain of the left side of the equation. So I'm going to continue anyway. Epiphany allows you to keep going if you think it's right, or even if you don't know if it's right, you just want to keep going and you want to keep going as it is. So I'm going to continue with this problem. I think I'm doing the right thing. And I'm going to say x equals 1 or 3. It's now going to compare this with the last step and say that's correct. And then finally, I'm going to go plug these back in. And what I'm going to do is I'm going to enter some text here. I'm going to insert a line of text. And it gives me the option to put some text in here. I'm going to backspace over that and say, plugging in x equals 1 is not valid. And I'm going to enter that as text entry without review. It doesn't check that, but it's something that will show up when you print out your homework. That's the reason to have a separate text entry here, is separate from the comments. The comments will not show up if you print it out as part of your homework, but these lines here would. And my last step is just going to be x equals 3. Now, once again, it's going to say that's incorrect because it doesn't match the previous step. And we're working on that. We have a new capability we're planning on releasing in about a month that will handle a whole bunch of domain issues for us, which will be really nice. I'm going to not worry about the comments here, and I'm just going to say that I'm going to continue anyway because this is right. And I'll mark this as done. And there we have it. There's a couple more problems I want to show you. I want to show you an entry of a problem involving complex numbers. So let's say I wanted to have a, call this problem number 13. I'm going to say x squared equals -4. And I'm going to leave this as a problem to solve in the reals. So, well, there's no solution here. So I can enter this as just an empty set, and that will be marked as correct. Or I can also mark this using the null set symbol in my functions and relations set right here. And that will also work. And I'm going to mark this as done. But let's go back and try this again. And this time, I'm going to set the domain to the complex numbers. You'll note that there's some other domains. I can use integers or custom intervals. I can set my own custom interval. I'm just going to stick with the complexes here. And now I can use the imaginary number I, x equals plus or minus, \pm is plus or minus 2I, and that will give me the correct answer in the complex plane. A couple more things I wanted to point out once you're done with an assignment like this, and I'll mark this as done as well. We can go back to our assignment and we can print this out. Your teacher can then, if you've shared access with them, use this QR code to access your assignment and look it over, or share comments on the problems you've gotten wrong. And it includes the mistakes that you made as part of the printout. We want to share that. It's good for your teacher and tutors to see where you've made mistakes. It'll help them to share information with you, and we'll also at times share information with you as the system on the types of problems that you've had trouble with. You can also run a report that indicates which problems you had trouble with. Let's say I want problems with mistakes. In this past week, here are the problems that I just ran today, and some of these are from another assignment I did earlier today as well. You can see those problems, and you can click into these to review them to see what happened in those problems. I also want to point out one more thing that I didn't show during the problem set. Let's say I want to review this problem later for my final exam. I can come up here and I can add tags to this, and I can say I want to mark this for final exam review later, and save that. And now I have that as a problem that I can look back at later if I want to. Thank you for your interest in Epiphany. We look forward to seeing you on the site, and please let us know if you have any questions.